టీవీ ఆపేస్తాను. Okay, good morning. Am I audible? Am I audible? Okay then. So let us solve some numerical problems on static error constant and steady state error. Okay, so the first problem. So for the unity feedback system with the g of s is equal to 125 by s into s plus 10, find the steady state error for an input u of t of first one 5t, 5 and 5t square. So these are our inputs. They have given us three inputs. For each input, we have to determine the steady state error. Okay. So here our input is u of t. So usually in control system, input will be r of t, but here in the question itself they have mentioned u of t. If they have mentioned u of t, then u of t is our input. That's it. So what is our first input? 5t. So consider input u of t is what? 5t. So determine the Laplace form of this 5t. So 5 is constant. Laplace of t is 1 by s square. So 5 into 1 by s square, you will get 5 by s square. Now, what is our steady state error equation? Steady state error equation, that's what I have written here, but I write that. I want to write that statement. So this is our steady state error. Standard equation for steady state error is ES is equal to limit S tends to 0, S into R of S by 1 plus G of S, H of S. This is our steady state error equation. Now, this is our standard equation, but in the question they have given, what did they give? Input as U of S, but in our equation we have R of S, so we can do one thing. So here instead of R of S, you can write U of S. Okay, instead of R of S, you can write U of S. U of S is nothing but R of S. So why we have replaced R of S with U of S? Because in the question itself they have mentioned input is U of S. That's it. So just write it down. If you complete, just mention in the chat box so that I'll proceed further. So instead of U of S, what you should write? You must write 5 by S square. Okay, instead of U of S, what you have to write? You have to write 5 by S square. So write 5 by S square here. Okay, what is G of S, H of S? H of S is unity feedback, means H of S is 1. What is G of S? 125 by S into S plus 10. So, what about in the next slide? We'll see. So, I have replaced U of S with 5 by S square and I have replaced G of S with 125 by S into S plus 10 and H of S is 1. So, go to the next slide, you just see. So, this is our U of S. Okay, this is U of S. This is G of S. Okay, this is G of S. H of S is 1. No need to write that. So that is it. This is our steady state error. Okay. So now whatever terms you are able to cancel, just before substituting the limit, cancel them. Here S will be cancelled. This S will be cancelled with this one of the S square is there. So 5 by S you will get. So 5 by S means you can write in the next slide, you can write 5 divided by S into 1 plus. That's what you can write. You just simplify it. No need for me to simplify again and again. You do the simplification. Okay. So my cursor, anyhow, my cursor won't listen to me. For that, I have to copy, paste and edit. For your sake, I can do that. I can do that. So if you simplify this further, what do you get? What you are going to get is here you will get the numerator 5 is left over. 5 divided by S. Okay, and I want a bracket here, so I will just insert a bracket for your sake, not for my sake. I don't know whether you people will be able to. You must be able to solve by now. No need to rely on me. This bracket I wanted here. Yeah. So now this whole term, you just insert here within this. Yeah. Remove this. Now this is it. See, if you simplify this expression, you will get this expression and multiply this S, and you can, since 5 is constant, you can send it outside the limit. Okay, so I have sent this 5 outside the limit, and this S, see, only 5 by S is left over. 5 by S you can write it as 5 in the numerator, S in the denominator. You can write like this. Okay, here S, okay, Okay, here s and s square is there. So s will be cancelled with one of the s. 5 by s is left over. So 5 by s you can write as 5 in the numerator, s in the denominator. And since 5 is constant, you can bring it outside the limit. You can write it outside the limit. And s, you just multiply it. You will get s plus, okay, s plus 125 by s into s plus 10. Okay, that's what you will get. Did I miss anything? Okay, SS cancel here actually. Yeah. So this here S you will get plus here in the numerator 125 S by S. So S cancel, 125 S plus 10 will be left over. You solve it. Okay, I'm telling you orally, but orally you can't accurately tell whatever you want, because writing is more effective than just reading. Okay. So you will get this. Now substitute S limit. Here this will become 0, this will become 0. So what is left over? 1 divided by 125 by 10. So 1 divided by 125 10 means 1 divided by 12.5. Here 5 is there. So 5 into 1 divided by 12.5. Okay. So what do you get is steady state error as 0.4. So if you are able to solve before head of me, then you can write the answers in the chat box, so that I will come to know that you people are following. If you have completed, just inform. So as soon as you complete, you solve. If you are able to get the answers, you just mention in the chat box, so that I will be knowing that you are able to follow me. U of t. Okay, so I will just copy the term which was there here. So this is it. I have simply copied from the previous slide. I didn't write steady state error. I wanted to write steady state. That's it. Nothing else. So u of t is equal to 5. So what is u of s? 5 by s. Okay. What is steady state error equation? Es is equal to limit s tends to 0 s r of s by 1 plus g of s h of s. So instead of r of s, since they have mentioned u of s, you write u of s. So limit s tends to 0 s u of s by 1 plus g of s h of s. Okay, so this is it. Simply we have replaced r with u, that's it, nothing else. So what is u of s now? 5 by s. So write 5 by s divided by 1 plus g of s. What is g of s? 125 by s into s plus 10. What is h of s? 1. Okay, now here if you observe carefully, in the numerator itself s will be cancelled. So this s and this s will be cancelled. What is left over? 5 divided by 1 plus 125 by s into s plus 10. So I have taken the common denominator here in this next equation. If you can see, s into s plus 10. Okay, in the denominator, in the numerator, 1 into s into s plus 10 you will get this plus 125. Okay, you just simplify. I have just simplified the denominator term. So 5, if you want, you can send it outside. Why? Because 5 is constant. So write it down. As soon as you complete, just inform. Okay, hope you have completed. Now here you just expand it. Okay, after expansion, means after multiplication and all, after simplification, you will get ESS is equal to limit s tends to 0, 5s into s plus 10 by s into s plus 10 plus 125. Now substitute the limit. If you substitute, you can see here, of course, yeah. So you can see here this s is there. So since because of this s, the whole term will become 0. Okay, because of that s. Because here it is 0. This is 0 when you substitute the limit. This is 0. This is 0. So what do you get? You will get 0. So steady state error value is 0. So if you get the answer, you just mention in the chat box if you are able to solve and if you are able to get the answers, so that I will proceed quickly. I will try to conclude this session within 1 hour if you are able to give me answers quickly. So I hope you mind this. Next, let us go for the third input. So what is our third input? U of t is equal to 5t square. So u of t is equal to 5t square. 5 is constant, t square. So Laplace of t square, you can see at the bottom of this slide. Laplace of t square is 2 by s cube. Okay, Laplace of t square is 2 by s cube. So what is u of s? 5 into 2 by s cube, that is 10 by s cube. Okay, so 5 into here, what is it? 5 into 2 by s cube. 5, I am unable to write 5 into 2 divided by s cube. Okay, this is 5. 5 into 2 by s cube. So 5 into 2, this is 2 by s cube. This is it. Laplace of t to t square is 5 into 2 by s cube. You will get 10 by s cube. That is our u of s here. Okay, so I will just make some modifications here. Simply I will copy from the previous slide the ESS. Okay, I'll just copy the ESS here. I just want to mention steady state error here, which I have not yet mentioned. I will just copy it and I will just paste it. That's it. I have copied that steady state error statement along with this and its equation. So this is it. ESS is equal to limit s tends to 0, s r of s by 1 plus g of s h of s. Here our input is u of s. Instead of r of s, write u of s. So limit s tends to 0, yes, u of s by 1 plus g of s h of s. Now substitute u of s term in this equation. In this equation, u of s and g of s, h of s is 1. So substitute it and simplify it. Here s is there, here s cube is there. 1, so s square is left over. So 10 divided by s square into this whole term. Okay, so you just simplify it. Okay, you will get the whole denominator term will become 0. So numerator will become, so anything by 0 is infinity. So ES steady state error, you will get infinity. If you complete, please inform. So I hope you might have completed. You try to solve on your own, so instead of simply copying it down from the slides that I'm showing it to you. You just try to copy it and do solve on your own, okay, and verify the answers. Okay, then now let us go to the next numerical problem. For the system shown, find what Kp, Kv and Ka means position error constant, velocity error constant and acceleration error constant. So which these three are known as what? Static error constant. Kp, Kv and Ka are known as static error constants. A block diagram has been given, and for this block diagram we have to determine these static error constants. So just write it down. Okay, so if we carefully observe in this image, it's a negative feedback system, isn't it? It is a negative feedback system, and this is our forward path gain. You just observe the arrow marks. Okay, this is our forward path gain. What is it? This is our forward gain. That means this is our G of S. Okay, this is our G of S. Now, if you observe here, this is feedback. This is feedback. So there are two feedbacks here. Okay, there are two feedbacks. Okay, this is our forward path gain G of S. This is our one of the feedback H of S. Another feedback is unity feedback. So there are two feedbacks here. Okay, one forward path gain is there. So first of all, let us solve this and determine the gain value for this overall system gain, overall gain of this system. Okay, so for that, let us initially eliminate this inner feedback loop. I'm even unable to draw this with my cursor. I'm even unable to draw a circle. Let us eliminate this inner feedback loop. This is our inner feedback loop. So let us eliminate it. This is G of S. Okay, this is what? G of S. This is our G of S. This is our H of S. And it is negative feedback. So what is the formula? To eliminate this inner feedback, what is the formula? Okay, what is the formula? What did I write? I have written G of S. Okay, I have written G of S here. It's okay, no problem. I didn't write T of S, even though I am solving this. Actually, what is T of S is equal to G of S by 1 plus G of S into H of S. So here I might have written T of S instead of G of S, but I wrote G of S instead of T of S. This is nothing but T of S actually, transfer function. But I wrote G of S. Why? Because further we have to simplify, and one more negative feedback element is there, isn't it? This is our negative feedback element is there. So this is not our final transfer function. That's why I wrote G of S, nothing else. Okay. So this is our, actually you just see, even though I have written G of S, what is this? This is G of S divided by 1 plus G of S into H of S. You just observe, this is G of S, this is upper term. Same thing I have written at the bottom, and this is H of S that I have written at the bottom. That means what? G of S by 1 plus G of S into H of S is nothing but T of S. But I did not write T of S here. Why? Because it is not our final transfer function for the given system. Okay. So just write it down, this G of S by 1 plus G of S into H of S. This is our H of S, this one. Okay, so if you simplify this, you will get 10 divided by s plus 1 into s plus 10. Okay, 10 divided by s plus 1 into s plus 10, and that's what you will get. So you can redraw the circuit. I don't know whether I have redrawn the circuit or not. I have to check. Yeah, in the next slide I have to see. I don't remember now. Okay, if you complete, I hope you might have completed. So you have to redraw the circuit. So this is our inner loop transfer function. So now redraw the circuit. What is it? This is it. R of s is equal to 10 by s plus 10 into s plus 10, and this is our h of s. What is h of s now? H of s is equal to 1, and this transfer function, this is for this circuit, or for this block diagram, this is our g of s now. Okay, this is our g of s, and h of s is 1. So my cursor won't obey me. Okay, so this is our g of s. This is g of s. This is h of s. So now what is Kp formula? Limit s tends to 0, g of s is Kp formula. Okay, g of s into h of s actually, not only g of s into h of s. So position error constant formula is limit s tends to 0, g of s into h of s is 1. That's why we did not write here. Okay, so similarly, velocity error constant formula is what? Limit s tends to 0, s into g of s into h of s. Okay, into h of s. Similarly, what is acceleration error constant formula? Limit s tends to 0, s square into g of s into h of s. That is the formula. Okay, but we did not write h of s here. Why? Because it is unity feedback system. H of s is equal to 1. So no need to write. Simply you can write limit Kp is equal to position error constant. Kp is equal to limit s tends to 0, g of s. That's it. Velocity error constant Kv is equal to limit s tends to 0, s g of s. Acceleration error constant limit s tends to 0, s square g of s. Okay, these three together are known as static error constants. Okay, now substitute g of s here. Limit s tends to 0. What is g of s? 10 divided by s plus 1 into s plus 10. Now there is nothing to cancel here. Substitute the limit s tends to 0. This will become 0. This will become 0. This will also become 0 when you substitute this limit. What is left over? 10 divided by 1 into 10. So 10 divided by 10, you will get Kp equal to 1. Similarly, Kv, limit s tends to 0, s into g of s. That is 10 divided by s plus 10, s plus 1 into s plus 10. So here you can't cancel this s with anything else. Substitute limit. So this will become 0. When you substitute the limit, this will also become 0. This will also become 0. So 0 into anything is 0. So velocity error constant is 0. Kv is 0. Acceleration error constant formula is limit s tends to 0, s square g of s. So limit s tends to 0, s square into what is g of s? 10 divided by s plus 1 into s plus 10. Now here this s square also you can't cancel it with anything else. So substitute 0 here. Substitute 0 here. Substitute 0 here. So what is left over? 0 into anything is 0. So even Ka you will get 0. That's it. If you want me to repeat, I can repeat. So you just take a minute, write it down. You try to solve on your own. You people try to solve on your own. Don't try to copy. Okay, I hope you have completed. I hope you have completed. Next numerical problem for the given system. G of s h of s is equal to k by s square into s plus 2 into s plus 3. Okay, so 1 second. So k by s square into s plus 3. Find the value of k. You have to determine the value of k to limit the steady state error to k to 10. Sorry. So steady state error is how much? Steady state error is given. ESS is given, that is 10. When the input to the system is R of t is given, that is 1 plus 10t plus 20t square. Okay. So this is what is given. So input is given, steady state error is given, loop transfer function is given. You have to determine the k value. This is the question. Now what is our input? R of t is equal to 1 plus 10t plus 20t square. If you observe this loop transfer function, what is the type of this loop transfer function? What is the type? Type 1, type 2 or type 0? Can anyone mention in the chat box? What is the type of this loop transfer function? What type is it? What is the type of this system? No, not loop transfer function. Sorry. What type of system is it? Type number. What is the type number of the system? It is type 0, type 1 or type 2? Of course, I have written there. What is the need to ask? Isn't it? It is clearly written. Yeah, it is type 2 system. Okay. So since the system is here, you can see in the loop transfer function s to the power of 2 is there. Therefore, it is type 2 system. So since it is type 2 system, okay. So for step input or for ramp input, okay, what will happen? Steady state error will be 0. For step input or ramp input, steady state error will be 0. Therefore, since it is type 2 system, you must consider, if you see here, these two, this input has 3 parts here, isn't it? One is constant, one is some constant into t, another part is some constant into t square. So, and we already know that for type 2 system, the input should be parabolic input, then only steady state error will be constant. What is our steady state error? He has already given a steady state error value, that is constant, that is 10. ESS is 10, means steady state error is constant. So steady state error will be constant for which type of input? Only for the parabolic input. So okay, so if you observe these 3 parts here, among these 3 parts, which resembles our parabolic input? Among these 3 parts, which resembles our parabolic input? Only 20t square. Only 20t square resembles the parabolic input when compared to the other 2 parts. Okay, they are not, they won't resemble the parabolic input. So you already know what is meant by parabolic input. Okay, so you should know parabolic input before solving these numerical problems. You must have the theoretical knowledge. So if you know the what is meant by parabolic input, you might be knowing that. So what is our input now? The steady state error will be constant only because of the parabolic input. So our input is only 20t square. So what is our input now? R of t is equal to, so even though the whole they have given us this input has 3 parts. One belongs to the step in, one resembles step input, one resembles ramp input, another resembles parabolic input, and we already know that for step input and for ramp input, steady state error will become for type 2 system. For type 2 system, for step input and ramp input, steady state error will become 0. But for type 2 system, steady state error will be constant for only for parabolic input. So this is our parabolic input. So r of t is equal to only 20t square. See, it's a twist here. Okay, it is a twist here in this numerical problem. So you can't take the whole input as it is and you can't solve the numerical problem here. Even though he has mentioned r of t is equal to 1 plus 10t plus 20t square, you can't consider the whole input as input. You can't take the whole input and you can't solve the numerical problem to determine what? To determine here k value. You can't determine the k value by doing this. Okay, so because we want steady state error to be constant for that particular input. So for type 2 system, if the system is type 2 system, here you can see s power 2 is there. So system is type 2 system. For type 2 system, input will be constant only for the parabolic input. So our input is only this part. So you have to consider only that part. So I hope you have written this slide. Okay, I hope you have written whatever is on this slide. So what is our input now? Only r of t is equal to what? 20 t square. So write down. So what is our input? R of t is equal to 20 t square. So what is r of s? 20 into t square. T square, just now previous problem I told you. Laplace of t square is 2 by s cube. So what is r of s? 40 by s cube. So r of s is 40 by s cube. Just write it down. Yeah, 40 by s cube is the answer. Someone has mentioned. It's good. Now let us determine the steady state error. We already know the answer for steady state error. What is steady state error value? It is already mentioned in the question. What did we mention? Steady state error should be 10, not more than 10. Okay, limit to, okay, k to limit the steady state error value to 10. Okay, so steady state error maximum its value is 10. For that we have to determine the k value. So what is our formula? A steady state error formula, the ESS is equal to limit s tends to 0, s into r of s by 1 plus g of s, h of s. So what is r of s? 40 by s cube. So 1 minute, here it is. Yeah. So here it is not 5, it is s. So r of s, what did I write here? Yeah, 40 by s cube. So s into 40 by s cube. So just simplify it to 40 by s square you will get. Send s square to the denominator. Okay, so you send s 40 by s square into. So I can modify this for your sake. I will write one more equation here. So I'm just inserting one. I'm writing one more equation. Just wait. So this is it. I have written, I have just whatever modifications that are there, I have done those modifications. So it may be of some use to you people. See here, 40 by s into s cube is there. So 40 by s square you will get. So 40 by s square into this, in the denominator, what is there here? Plus is not there, sorry. Here 1 is at the numerator, yeah. One more modification, wait. This is it. So this is it. Limit 40 by limit s tends to 0. 40 by s cube is there. So 40 by s square. So limit s tends to 0. 40 by s square. Instead of writing in the numerator, you can write it in the denominator into this whole term, whatever was there as it is. I have written 1 plus k by s square into s plus 2 into s plus 3. Okay. Now you just send this s square inside within this flower bracket, isn't it? You can see the flower bracket here. So if you send this, I will take the laser. So if you send this s square inside, so s square plus k into s square by s square into s plus 2 into s plus 3. So s square cancel. Okay, if you want, I will write one more equation. I can write one more equation. You can do it. You have to do, isn't it? It's your call. It's your call. You have to write the exam, so you people you have to solve it. So one more step you can write on your own. Simply multiply s square within this flower bracket, and you will get s square plus k into s square by s square into s plus 2 into s plus 3. K into s square, here denominator s square is s square cancel. So s square plus k divided by s plus 2 into s plus 3 you will get. Substitute the limit now. 40 is constant, so forget about it. So limit s tends to 0, s square, it will become 0 plus limit. When you substitute limit here, this will become 0, this will become 0. So k by 2 into 3 you will get 2 3s are 6. So 40 divided by k by 6. So if you have not understood how you got this 40 divided by k by 6, if you have not understood, you just mention in the chat box. I will write one more equation. If you are able to follow or not, you just tell me how you got this 40 divided by k by 6. If you are unable to understand, I will write 1 or 2 steps extra. I think 1 step is more than sufficient. Maybe I can write 2 more steps. Completed. So did you understand 40 divided by k by 6? How did you get? Anyone, if you are unable to understand, if you didn't get that 40 divided by k by 6, you just mention. Did you understand or not? Please mention. It's very simple actually. No one has mentioned. I don't know. You are able to follow or not. You didn't mention whether you have understood how did you get this 40 divided by k by 6. Simple. Actually, simple mathematical simplification. Nothing is there. But I don't know whether you are able to follow or not. That's why I'm asking you. It's okay. So what is ESS? 40 divided by k by 6 you will get. So you just send this 6 to the numerator. You will get 40 into 6 by k. So what is ESS? 10. So 10 is equal to 240 by k. So what is k? K is equal to 24. K is equal to 24. It's simple. It's not complicated. Okay. So 1 or 2 steps I didn't write directly. I have left the simplification to you people. It's very easy. It's very easy. Nothing complicated. Only the thing is you have to put your pen on the paper and you must try to solve it. If you are able to solve, you can do it. It's very easy. So I hope you have completed. Let us go to the next numerical problem. Okay, so for unity feedback system, so for a unity feedback system means h of s is equal to 1 has g of s is equal to k into 2s plus 1 by s into 4s plus 1 into s plus 1 square. This is our g of s. H of s is 1. Find the value of k if the steady state error is less than 0.1. So steady state error value they have given which is less than 0.1. Okay, it's not even, they didn't even mention whether it is equal, they didn't even mention that it is equal to 0.1, but they have mentioned that it is less than 0.1 when the input to the system applied is this. Okay, so input to the system that is applied is what? 1 plus 5t. Okay, so 1 plus 5t. So how to determine the k value? So input is what? R of t. Okay, R of t is 1 plus 5t. If you take the Laplace of this R of t, what do you get? 1 by s plus 5 by s square. So 1 by s plus 5 by s square. Okay, so you can rearrange the terms. You can rearrange the terms and you can rewrite it as 1 by s square into s plus 5. Okay, you just take the common denominator and you just simplify it. You will get 1 by s square into s plus 5, or you can leave it as it is. No need to even modify it. If you don't want, don't modify it. Okay, so you can further modify by taking the common denominator, and by further simplification you will get 1 by s square into s plus 5. You just write it down as soon as you complete. Someone has a doubt, you just type it in the chat box. Previous numerical problem, if you have any doubt, you just mention in the chat box, I will clarify it. Or you want me to repeat the previous numerical problem, I will repeat it. From which slide you want me to repeat, you just mention repeat in the chat box. That's what I was asking earlier. In the previous, while I was showing previous numerical problem, I was asking you. If you want, I will write 1 or 2 steps extra so that it will be more clearer to you. So did you complete? Whoever is writing? So whoever has mentioned, who have doubt, you just mention in the chat box. Do you want me to repeat the previous numerical problem? So it seems somebody is whoever this is, it is too much. So whoever some unnecessary message is typing, okay, so if you don't want to attend the class, just leave the okay. So unnecessarily don't overact. Someone, I don't know who you are. If you want me to repeat, I will repeat. If you want me to write anything, I will write. Okay, I don't know who you are. You are writing something rubbish in the chat box. Okay, so you don't know simple mathematical simplifications, and if you ask unnecessary, I don't know what, you are not even clearly typing what you want. What is your doubt? You are not even mentioning in the chat box, and you are writing something rubbish. Okay, what do you think about yourself? If you don't want to attend, don't attend. Someone? I don't know who you are. But if you don't want to attend, don't attend the class. If you are unable to follow, why are you attending the class? If you have any doubt, you just type in the chat box. I will reply to your message. If you don't want, why are you attending? You don't have interest at all. You must have the basic knowledge, minimum basic knowledge of this concept, theoretical knowledge. If you have the theoretical knowledge of this concept, you will be able to follow the class. Okay, whoever are regularly attending the classes, they might be following. Who are you? I don't know who you are. Some Balaya something. Okay, so let us proceed. That person who has mentioned he wrote something rubbish, and he's not even asking his doubt. He's wasting my time. Okay then. So just this is our input. He didn't even mention. Of course, by looking at the system, you can see feedback is unity feedback. G of S is this is G of S, and by looking at the system, we can say it might be type 1 system. Yeah, of course, it is type 1 system only. So for type 1 system, of course, you can consider, instead of considering the whole input, as I said for the previous case, you can consider only, what is it? You can only consider phi of t. You can write, okay, I have written whole term here. You can write r of t is equal to phi t, and you can consider that input itself. That is also correct. Okay, I hope you have written. Meanwhile, I was wasting my time with someone, talking about someone. Okay, so now what is the formula for steady state error? Steady state error is equal to limit s tends to 0 s r of s by g of s h of s. Simply substitute that r of s here. Okay, simply substitute the r of s here, and write 1 by g of s, whatever you have got, you just write it down here. So no need to even have written, but no need to consider this part. Anyhow, it will become 0 actually. If we take the Laplace, 1 by s, of course. Of course, for Laplace, you will get 1 by s. Okay. So, but no need, because it is type 1 system. Okay. You can consider only phi t. And you can solve. That is also correct. Okay. Now, so just substitute r of s and g of s. H of s is 1. And just solve it. Okay. Solve it, and if any terms cancel, you just cancel them. Okay. And simplify it. You will get steady state error equal to phi divided by k. Just write it down. As soon as you complete, you just mention in the chat box. So I hope you have completed now. So ESS we have got what? 5 divided by K. So 5 divided by K you have got, but what did they mention in the question? Steady state error must be less than 0.1. So 5 divided by K must be less than 0.1. Okay, so what do you get? K, send K to this side and 0.1 to the denominator side. You just interchange the positions of 0.1 and K. What do you get? K is greater than 50. So K should be greater than 50 for ESS less than 0.1. Only one numerical problem is there within 5 minutes. This class will be concluded, 5 to 10 minutes. So I hope you have understood this numerical problem. So one twist that I didn't mention, I did not consider, but you can consider. I have written as it is. One thing that you have to consider here is, since it is type 1 system, you can simply consider R of t. Instead of considering 1 plus 5t, you can consider only 5t. If you consider 5t, that is correct only. Here I have simply, I didn't go specifically, means I have whatever input that is given, I have considered the whole input. No need to do as I have done. So you can, to be more specific and to be more accurate, you can do this 5 by s square. You just substitute R of s here. You clearly mention since it is type 1 system and so on, so you can write like that. Okay. So that's it. I hope you have understood. Next, this is the last numerical problem. So here, a unity feedback system. I will take the laser. A unity feedback system has g of s is given k by s into s plus 1 into s plus 2. Find the value of k if the steady state error is less. Same thing, isn't it? Same. Am I repeating the same problem? No, I'm not repeating the same problem, isn't it? Yeah, I'm not repeating the same problem, but it is similar to previous case. Okay, find the value of k if the steady state error is less than 0.1 when the input to the system applied is unit ramp input. So unit ramp inputs he has mentioned. You must check this g of s. Okay, so s to the power of 1. So s to the power of 1 means type 1 system. So for type 1 system, we already know, for type 1 system, for unit ramp input, steady state error will be constant. So this input is satisfactory. This input is satisfactory. So R of t is a unit ramp input. So R of t is equal to t. So R of s is equal to 1 by s square. Okay, so I will erase all inks. So what is steady state error? ESS is equal to limit s tends to 0. Yes, R of s by 1 plus g of s, h of s. So it's simple. This if they simply, if instead of giving input values, if they simply mention ramp input or parabolic input or whatever, so even if they won't mention the input type of input, we can assume the type of input depending on the system that has been given. Simply whatever g of s is given, and if a feedback system, usually they will mention it as unity feedback. So depending on this power, we can decide the type and input. That's it. So you must have the basic knowledge of the steady state error concept, theoretical knowledge, then only you will be able to understand. Okay, so this is our input in Laplace. This is our steady state error equation. Now what is left over? Substitute the g of s and r of s in that steady state error equation and simplify it. Did you complete? Okay. So what is it? Steady state error. If you simplify this, you will get ESS is equal to 2 by K. Okay, here S is there. 1 S will be cancelled. So 1 by S. So 1 divided by, you will get, I can add one more equation here. So what will happen here is, here it will be 1 divided by, here you can write S into the whole denominator. So I'm going to insert an bracket here. It's better to insert here. Okay, so you will get like this. So S and S square is there. So 1 divided by S into this whole denominator. 1 plus K by S into S plus 1 into S plus 2. Now just multiply this S with this whole term. You will, and substitute the limit. So limit S tends to 0, yes, it will become 0. And the limit S tends to 0, S cancel. This S when you multiply, S cancel. K divided by S plus 1 into S plus 2 will be left over. And when you substitute limit S is 0, this also becomes 0. So K divided by 1 into 2. So K divided by 2 you will get. So 1 divided by K divided by 2. Okay, 1 divided by K divided by 2 you will get. So that also I can add here. This is what you will get, 1 divided by K divided by 2. So that you can rewrite it as 2 divided by K. Okay. So steady state error is equal to 2 divided by K. So what is steady state error value? It is less than 0.1. So 2 divided by K is less than 0.1. So you just send K that side and 0.1 this side. You will get K greater than 20. So value of K is greater than 20. That is the answer. So if you have doubts, you just ask. Otherwise, my class has been concluded. Okay, nothing is left over. So please don't post unnecessary messages. If you are unable to follow, you just mention in the chat box if you have doubts. If you are unable to follow, just leave the class. Whoever is attending the class, okay. So if you are unable to follow, don't attend. Who is forcing you to attend the class? Okay, don't post unnecessary messages if you are unable to follow the class. Unnecessarily, don't waste your time with me. Okay, if you are unable to reach me, if the lecture delivered is not clearer to you, it is of no use to you, so don't waste your time with me. Okay, Mr. Balaya, whoever, don't waste your time with me. You are unable to understand my lecture, just leave my class. That's it. Don't post unnecessary messages. Don't give me unnecessary advices. If you are unable to follow, that means that you don't know the basic knowledge. You don't have the basic knowledge of this concept. That's why you are unable to follow. That's why you are getting doubts. That's the reason, because each and every step is clearly written on the screen. Even if you are not listening to my class, even if you are not listening to what I am speaking out, okay, if you have basic knowledge of multiplication and division, you can easily solve these numerical problems. Nothing complicated is there. Okay then, class is over.